Jane's TV dilemma. We know that Jane has a 240 square foot wall to hang a TV on. That could be a wall that is 8 foot tall by 30 feet long, or it could be a wall that is 10 foot tall by 24 feet long. I'm approaching Jane's TV needs from the perspective of viewing angle. I teach pre-calculus at University High School, and we're going to use trigonometry to solve this problem. Now, from the picture, you can see where the couch is located. This is where the person would be seated. The viewing angle is formed from the perspective of the person sitting on the couch looking towards the width of the TV. You can see a triangle that's formed. Recommendations that I found on a website. The websites are listed in my attachment that you'll find, a Word document. Recommendations, THX recommended a 40-degree viewing angle for maximum cinema immersion. SMPTE recommended a 30-degree viewing angle, and CNET recommended a 32.5-degree viewing angle. THX is the George Lucas subsidiary company known for surround sound. SMPTE stands for the Society of Motion Picture and Television. And then CNET is just a technology web address. So as you can see from this picture, the triangle that's formed is isosceles, which means at least two of the sides are congruent. You also have this average seating distance from the television. Most of the websites I looked at said that would be about 9 feet. So I've converted it to inches, multiplying by 12. So what we're going to use is some geometry to deduce more information about our triangle. For the purpose of the video, I'm going to use the THX angle, which is 40 degrees. So you can see that this line of distance from the television to where the person was seated on the couch is it's going to take, and it's going to cut that triangle in half. So that makes it an angle bisector, an altitude, and a perpendicular bisector all rolled up in one. So now we're going to have two congruent triangles that are formed, which means that 40-degree angle got cut in half so that we have two 20s. And then we have this distance right here, which is still 108. And then what we're going to be solving for is half of the width of the television, which we're going to call X. Using trigonometry, specifically tangent, we can solve for the short leg or side. Tangent, by definition, tangent of theta is equal to opposite over adjacent. So when we plug in the angle, which is 20 degrees, tangent of 20 degrees is equal to x over 108. We cross multiply, we get x is equal to the tangent of 20 degrees times 108, which is approximately 39.31 inches. So the width of the television is going to be twice that. And so if we take twice that, we get approximately 78.62 inches. Now, today's HD TVs generally have a 16:9 aspect ratio. And if you look closely at that value is very close to what we know as the golden rectangle, which is also called phi. Don't know if that's what they were thinking about when they created that ratio, but it's kind of an interesting thing to investigate. The golden rectangle is that shape of a rectangle that everybody finds appealing. It's about the right size. It's what people think of when they think of a rectangle. Anyway, we have this proportion. 16 over 9 is equal to 78.62 compared to the height. And now if we cross multiply and divide, we're going to get the height is approximately 44.22 inches. Finally, on our last step, to determine the diagonal size of the TV, we now apply the Pythagorean theorem. Our width squared is going to equal the diagonal squared. So 78.62 squared plus 44.22 squared is equal to d squared. We square root both sides, and we get that the diagonal is approximately 90.20 inches. And this is approximately the size of the television recommended by THX for maximum cinema, or otherwise known as surround sound. You would follow the same procedure to determine the dimensions recommended by SMPTE and CNET. And I've shown that in my Word document that is attached to this. Other things that you would take